The topic of my poster is AI-driven classification of AI/ML applications in accounting research. I'm conducting my research under the AI Doc grant at the University of Warsaw under the supervision of Dr. Miko Ranta. The aim of this project or poster is to understand how accounting research, particularly in the field of AI and ML, has evolved over time using AI and ML methods. Why is finding out about the evolution process important for us? Because it helps to analyze changes over time. By grouping research topics from different periods, we can see shifts in focus and emerging trends. It gives us valuable insights into the field's development. We use two complementary AI-based topic modeling approaches. The first one is LDA sequential model, which is a word frequency-based method that captures topic evolution over time. And the second one is BERTopic. It is a semantic-based method and it detects conceptual shifts toward the time, and it detects a topic based on the concepts and semantic data analysis. Using these methods, we uncover how accounting research has transformed from 1995 to the present. This analysis not only highlights past and current trends, but also helps predict future directions in accounting. Our dataset comprises research articles from all accounting journals ranked B, A, and A+, ensuring a high quality and comprehensive analysis. In the methodology, we have three main parts. The first part is about reading PDFs. It means that we extract and clean the bunches of PDF files. After this step, we go to data analysis of these data of PDFs. For extracting and cleaning part, I use this flowchart. The first step is to detect and choose your PDF library. The PDF library completely depends on your purpose. If you don't know which PDF library is the best for you, you can visit my LinkedIn, which I explained there. The next step is to parse the PDF file. What does it mean? The PDF file is just like a locked box, that it has lots of text, images, fonts, tables, layouts, and so on. Parsing step enables us to open this closed box and get the data out of it. Then we use LA params, which we can detect the layout from it, and we analyze the parameters that are related to layouts. And PDF page aggregator, it will collect all the data together. So for example, from LA params, you have the layouts, you have text, images, graphics, and so on. So these data are gathered together using PDF page aggregator, and then we use PDF page interpreter. So it means that it will process the context, it will read each element, it will, for example, so based on PDF page aggregator, it detects that you have text, so it will read this text. It detects that you have, for example, layout, so it will find out that how to read the PDF. If it has two columns, the reading process is different with one column, and so on. After this step, go to dividing the PDF file into single pages and extract the text from each single page, interpret the data in it, and using the interpret function. Completely this depends on the layout, if it has tables, pictures, and so on. So there's a loop until the end of the PDF file. At the end of this loop, so we have extracted the data of the PDF. So we have the text files. Here, it is ready to do some cleaning. For example, I use Gensim to tokenize it, use lowercase words, removing punctuations, and the cleaning part. Then I use stop words and also postages. I remove the stop words, then I remove, I just allow the postages that I want. For example, depends on your purpose, you just need nouns, so just select the noun, or maybe you just need noun and adjectives, or all the types. It depends on your purpose. So based on my purpose, I use my noun and adjective words. Then I define the bigrams. What does it bigrams means? For example, in the text, New York is beautiful, I have 3 words. New York is beautiful, because these New York are written separately in most texts. Or for example, artificial intelligence, they are separated. Bigrams detect that these 2 words are almost beside together, so these are actually one word. So it will change the separated words into one word using slash between them. And after this step, we remove rare words. It means that those words are appeared in less than 2 papers. Or we remove very common words, which means that they are used in more than, for example, 80% of documents. Next step is to define bag of words. So for each document we have in bag of words, we will make a word ID and the frequency of it. For example, it detects that in paper number 1 with the name X, the word artificial intelligence, which is bigram, repeated in the PDF, for example, 13 times. So that we have the frequency. So for each PDF, we will make bag of words and then gather all this data together. So we have a list of lists of bag of words. The second part of the methodology is LDA sequential model. LDA sequential model is a method that clusters the articles or research in PDF files into topics based on word frequency. So we extracted the word from the files. Now we have them in bag of words, and LDA sequential model cluster these PDF files based on word frequency. So it detects some topics for the whole packages of the PDF files, and it assumes that each PDF is belong to multiple topics with different probability, and this probability depends on the most important words and their frequency in the PDF file. So it groups articles or PDF files by looking at which word is commonly appear. The next one is BERTopic. The BERTopic, instead of working on frequency of the words, it works on the semantic type of the sentences. For example, we have 2 sentences with words, the artificial intelligence is beautiful. Another sentence is that artificial intelligence and machine learning are making our world better place. The BERTopic assumes that these 2 sentences are the same. So it works with meanings of the sentences. And then, depending on the meanings, it starts to clustering the articles. In the results section, first we are going to look over our dataset. As you see here, we have the number of accounting articles related to AI and ML per year that are published in top journals. And so the x-axis is the year and the y-axis is the number of public. What was our purpose? Our purpose was to cluster the PDF research and PDF papers and to find out the evolution of these clusters. To finding out the evolution, we should define the time slices. As we see from this diagram, from this bar chart, we have some years that the number of publications is very low. It is minimal activity here. Then we can see the growth, for example, around 2015 to 2021. That is, shows the growing interest in this area and using and applying AI and ML in accounting. Then we can see that in 2022 and 2024, we can see a rapid increase, which shows the rapid adoption and implementation of AI and ML. The point is that we should detect the time slice precisely. We cannot just define the time slice by looking at the data. We should have restrictions and define very clear method to select a time slice. To do this, I used a trend. So I fit line, as you see in the table, one line is exponential trend, another is linear trends, and also I used other type of trends as well, but here I just mentioned two of them. And then I tried to minimize the R square. First I fixed the starting point and then changed the ending point. Then I fixed the end point and changed the start point, and do it multiple times to find out the best time slices. For example, assume that my starting point is 2015. I changed the ending point from 2017 to 2024, and I found out the R square of the trend in two different methods, exponential and linear method. Here the color red means that it has very low R square. The green means it has very high R square. And we know that the best R square is the one that is closer to 1. So we're looking at the green cells. At 2021, we can see that we have green cells in both methods. So I define three main time slices from 1996 to 2014, 2015 to 2021, and 2022, 2023, and 2024 for the last time slices. And as you see, I defined them here, that the first time slice is minimal activity, foundation period. The second one is growing interest and research driven by advancements in AI and ML. And the last one is rapid adoption and implementation phase of AI and ML in accounting research. The second part of the result is about LDA sequential model. As we mentioned, the LDA sequential model will cluster the PDF files based on their topics and based on their frequency of the words or keywords. The point is that this method will not detect the best number of topics by itself. We should set the number of topics as an input. So the first question is that what is the best number of topics? So I use different number of topics from 1 topic to 8 topics and detect how the topics will change by increasing the number of topics. And I see that when I change the number of topics from 7 to 8, in the 8 number of topics, I see the overlap between topics. So because the result of LDA is bunches of keywords for each cluster, and from 7 topic to 8 topic, I can see that the keywords are overlapped in different topics. Therefore, I can see that the 7th topic is the best number of topics, as it is the maximum number of well-separated keywords and clusters. So we continue with 7 topics, and they are auditing analysis, ESG reporting, financial analysis, financial government, fraud detection, market dynamics, and social responsibility. And these names are made from the keywords, the main keywords of each cluster. For each PDF, we have the probability of belonging to these clusters. For example, PDF number 1 has the probability of being in a cluster 1 with 0.1, in cluster number 2, for example, with 0.13, and so on. Using average over the probability of belonging a PDF to a specific cluster, we can see that how clusters change over time. Or using the average value of papers in each topic over the years enable us to identify the portion of titles over time. Here in figure 3, you can see this. The main 2 topics that we have here and happens before 2015 are market dynamics, which is the red one, and the dashed one is financial analytics. We can see that by increasing the time, the portion decreases. It doesn't mean that the number of papers are decreased in this area. It means that the other clusters are increased, so they are decreased as an affection of increasing of other clusters. Between 2015 and 2021, we can see an increase in fraud detection it becomes the most attractive area and it gained the largest portion. And from 2022 to 2024, we observed the growth in all areas actually. Here you can see with a nearly equal portion for all topics. As you see, they almost have the same portion except the fraud detection, which have the most part. The last part of the result is about BERTopic. In the BERTopic, unlike the LDA sequential model, the best number of topics will be detected by the model. Here, the model detected 3 main topics, as you can see here. These are topic 0, 1, and 2. Topic 0, based on the keywords, I named it fraud detection and financial analysis. Next one, corporate tax compliance and avoidance. And the last one, accounting and financial research. So here we can have the keywords, some of them here, and in the next slide we can see the number of papers in each cluster. As you can see, most of them are in the accounting and financial research. One more time, that BERTopic does not clustering papers based on the keywords. It clusters based on the semantic and meaning of the words. So when a paper around accounting research can have the same methodology and methods and a roadmap as the financial research. So both of them will categorize in the same group. This is why we can see lots of papers are in accounting and financial research, because all of the papers are about accounting, but of course based on the type of working and the way of methodology, it found 3 main topics. One can go further and choose this main topic and goes down to see what happens when we cluster just this group. Maybe in next poster or video I will explain what will happen when we do this. So in conclusion, we can see that in the BERTopic analysis, we found 3 main categories, with the largest one focused on accounting and financial research. LDA sequential model, also we used it, and we analyzed word distribution to see how much each article contributed to different topics, and we found the clustering of topics based on this method. So we saw that fraud detection is increased based on time, as for example you can see also here. We categorize it based on time. We can see that in both methods we see the increase in fraud detection based on time. So nowadays more articles are working on fraud detection comparing to the past. And accounting and another topic that is increased so much is accounting and financial research, which we saw it in BERTopic. Combining these methods and the results of combining these methods, we not only identify the main topics of the articles, but also gained a better understanding of the common perspectives and research methods. Thank you very much. Have a good time.